All right, thanks. Paul, could you just confirm that you can see my first slide?
Yeah, I can see it, yeah.
Great, all right, thanks very much. Okay,
Cool.
all right, let's get started. Good afternoon, ladies and gentlemen. My name is Glenn Bradshaw. I'm product responsible for VRV with Daikin, South Africa. And I'm going to be presenting 3 Monday afternoon sessions based on VRV installation. And we're going to be looking at a couple of items that pertain to getting a correct VRV installation and being able to get through a successful commissioning. So this afternoon, we're going to start off with session 1. Okay, session 1, we are going to take a look at the documentation available to you, as well as some service apps. We will also be looking at the correct installation of indoor and outdoor units. And then next week, we'll move on to some piping and wiring, and then the pressure test and vacuum. And the following week, we will look at the steps to get through the final commissioning of a project. Okay, all right, so let's begin. In any successful project, planning is essential. If you fail to plan, then you might as well plan to fail. Whether you plan or not, you are planning. So choose to plan for success. Okay, one of the biggest failures that I think we all see within our industry is when planning is not being thought through and it's incomplete. And when we get to the final steps, we find that there are things that haven't been done properly or things that are missing. All right, so let's see if we can try and eliminate those, and we can get our head around some of the things that are required in order to get a successful VRV installation done. All right, so we're going to start off looking at the documentation and the business portal. These are applications that are available to everybody out in the field, our contractors and our dealers, and it helps them get the documentation together that they would need to give installation technicians and project managers, okay, so that they can start working towards a successful project. We're going to look at document types. We're going to look at the business portal. Okay. We're going to look at common mistakes on the business portal just to try and help you navigate your way around it. It does take quite a bit of practice. There's a lot of information on there, and you actually need to be very much aware of what you're looking for. Okay, and then we're going to look at 2 Daikin apps available to members that have got their feet on the ground, that will help them get through some of the steps that they need. All right, so documentation in the business portal, and as I said, we're going to kick off with document types. And of course, document types, the very first document type we're going to look at is a data book. Okay, the data book is something that the sales or project manager would go to, and this would also just guide them in the right direction in terms of the capacity of the equipment, some of the information about it, SER and scope, minimum, maximum indoor connection ratios, some of the dimensions, the weight, compressor quantity, crankcase heater capacity, things that pertain, engineering data that pertains to the unit that you're busy installing. Okay, you get data books both for the outdoor unit and for the indoor unit. Okay, some more information that's in there includes center of gravity, which will help when it comes to lifting equipment, some piping and wiring diagrams, okay, and so on, right through some sound data, and then also the operational range of the unit. Okay, very, very important documentation. Okay, and it's a good idea that you actually have this documentation for all the equipment that you're installing at the time of doing a VRV installation. Okay. This is documentation that you will find that is coupled into every single condensing unit or indoor unit that we supply. It is the most underread document. Very often we'll arrive on site and still find this wrapped in its plastic. But if the technicians who are installing the equipment would read this document, they could save themselves a lot of problems at the end. So I'd really recommend that the documentation is taken out of the units, opened up and read. And if you don't understand something, that is when you're welcome to phone us and we can help you. Okay. And some of the installation things in there, in fact, it gives you a complete guideline of how to install the units. Right, and that's everything from brazing, the stop valve service ports, the tightening torques, leak test, vacuum drying, piping installation, refrigerant charging, field wiring, and right the way through, right through to the test run, and even some basic fault finding should you have any issues on site. Okay, all right. That's the second type of documentation. And it carries on. There's a symptom-based troubleshooting that I was talking about. It's very, very basic. Get you going. If you need some more advanced topics on troubleshooting, okay, then you will need to go on to the service manuals. The service manuals are available on the business portal. You can download them in an electronic format. And again, I highly recommend that service teams, service managers, and installation technicians make themselves aware of what's in this book. Okay, and these books contain field settings, pipe diagrams, wiring diagrams, a component overview, product-specific items, as well as switchbox layouts. Okay. All right, and it takes you through all of those. So those are very important documentation that you're going to need, and I recommend that you make yourself familiar with them. Right, the business portal. This is a portal which you will find, the link to it is the link that we've got down below here. Okay, it's basically if you just search my.daikin.eu, it'll take you onto that. Okay, you'll get a screen that looks like this, and if you haven't registered, basically what you need to do is enter not registered yet, and it will bring up the following form. You click on it, and you complete that form with the information. You'll see that most of the information on there is mandatory. Okay, and then you will then be able to select your email as your username, your password, and then you'll be able to sign in to our business portal. Okay. And that's what should open up once you're inside it. All right. It's got a search bar. Okay, we're going to discuss how to get around those and make sure that you get the right information. There is a lot of information on the business portal pertaining to all our products that are sold in Europe. So not all of them available here in South Africa, but it's very important in looking for equipment that you search in the right categories. Otherwise, you're going to get pages and pages of irrelevant information. Okay, so if you want to search for anything, basically, if we're looking over here at a VRV unit, RXYQ, T-series, okay, you'll type that in. And then what you can do is you can set up your filters. Okay, so obviously you'll check English, and you will then set up for the type of product documents that you're looking for. Okay, and those are the filters. Okay, and you can tick those off. If you tick everything, you're going to get a lot of information, so rather try and be specific in what you're looking for. Like I said, it takes a bit of time, but if you spend an hour or so on the site, you'll get a pretty good feel for how it works. There's some common mistakes that are made on the business portal. Okay, it says that always use unique Daikin product names. Okay, so if you go and type, for instance, VRV outdoor unit, you're going to get the information for probably most of the VRV outdoor units in the last couple of years, which is going to not probably pertain to the one that you're looking for. Okay, and if you look down the bottom there very quickly, there was about 2,000 documents already by not searching specifically. Okay, there we are, ticking off the right ones that the person wants. And you can see the list is getting shorter. Okay. All right. For instance, if we actually type in now an actual model number, immediately you will see that it brings up an area where all the documentation for this water-cooled VRV will be pertained. So once you open it up, only the documentation for that is in that area. Okay, and you'll see there's everything from marketing to sales to service information. Okay. Most of you guys in the technical field will be looking through the sales and service. There won't be much need for you to go look for marketing stuff. Okay. So we'll just let that play out. Okay. Right. So we've gone through the videos. I'm going to cut that one over there. Okay. And now we're going to look at two apps that are available. These are cell phone based apps or mobile apps. And the first one is relatively new on the market. We're trying to get more and more people to sign on for this. And this is called the Daikin eCare app. Okay. And there it is over there. Okay, this is the symbol that you'll see if you look for it on any of the Google Play or iPhone stores or Apple Store over there. And we're going to kick off with just a short video where somebody's going to just explain the app. And then we'll have a look at just a little bit closer at some of the features inside the app.
Hello.
Hello? Hello, sorry, did somebody call?
Glenn, hi. There's no audio on this, huh? It's Nishal here.
Hello?
Hi, Glenn. It's Nishal
Hi.
here.
Hi.
There's no audio on this, eh?
Is it?
Well,
Okay, hang on.
I can't hear anything.
Okay, let me see if I can correct it. Sorry there.
Sure, no problem.
Okay, so we can just get back there. Sorry, I think what's happened is that the sound is not sharing. Yeah.
Hello, my name is Lore, engineer of the Daikin Europe Technical Service and Control Division. With this video, I would like to introduce Daikin EDoctor, part of eCare, an application to guide our Daikin colleagues and install shooting a unit. Let's get started. Here you see the home screen of the eCare application, where we can open EDoctor, start a new session, or you can also continue a previous session. We'll come back to that later. Now we will start a new session. Selection of the unit can be done via QR code scanning. If you want all available information to be visible, please make sure you scan the inner unit, outer unit, and other applicable components. If you are not Hello, my name is Lore, engineer of the Daikin Europe Technical Service and Control Division. With this video, I would like to introduce Daikin EDoctor, part of eCare, an application to guide our Daikin colleagues and installer in troubleshooting a unit. Let's get started. Here you see the home screen of the eCare application, where we can open EDoctor. You start a new session, or you can also continue a previous session. We'll come back to that later. Now we will start a new session. Selection of the unit can be done via QR code scanning. If you want all available information to be visible, please make sure you scan the inner unit, outer unit and other applicable components. If you are not in front of a unit or the unit does not have a QR code, you can also enter the model name and serial number manually. We have an autocomplete function for the model name, so this will make finding a model easier. This is the home screen of EDoctor. On top you can see the details of the service manual where EDoctor finds its information. A service manual is available on the business portal if you prefer to work on paper or on a personal computer. We provide 3 starting points for our troubleshooting: error and symptom-based troubleshooting in case you have an error or if the unit is acting strange. In case you already know which component you want to check, you can go to the component check. If you need help in the removal or the installation of a component, you can use the component repair. First, we will go into detail of the error and symptom-based troubleshooting. A full list of all error codes is provided. You can find your applicable error code by scrolling or by entering it into the search bar. We give you the trigger for each error code, the effect this will have on the unit, and how to reset the error code after you found the root cause. EDoctor guides you in how to solve the error code by giving you a list of components to check in a recommended order. Let's check, for example, the water flow sensor. By pushing on this tab, EDoctor continues the component check of the water flow sensor. We want to check the component. For this part, only an electrical check is available. Step by step, we show you how to make sure the component is functioning as expected, or if it's broken. At the end of each component check, you get a question. Depending on your answer, EDoctor knows what the next step is. Let's say the result is that the flow sensor needs to be replaced. EDoctor will now continue with the repair procedure of the flow sensor. You decide you need help to remove or install the flow sensor. EDoctor gives you all removal and installation procedures using clear instructions and pictures. We now finished an example of how the EDoctor guides you from error code to parts replacement. Let's go back to our troubleshooting and focus on symptoms now. In the symptom-based troubleshooting, we'll find a list of all known symptoms. Each symptom can have more than one possible failure. A root cause, check, and repair instruction is given for each failure. When we go back to the home screen of EDoctor, the second possibility is to start your troubleshooting with the component check. A list of all components is given. You can either scroll to the required component or you can use the search function. Depending on the component, you can have different types of checks: electrical, mechanical, position check, or others. By selecting your check procedure, EDoctor will give you clear step-by-step instructions and pictures to help you. The last of the 3 start points of troubleshooting is the component repair, in case you already know which part needs replacement. Select the component. Select if you need help in the installation or removal of the part, and find the required instructions. As a last feature, we provide technical info of our units that can be required during troubleshooting. We give the wiring diagram, piping diagram, a component overview, and other required information. Here you can see an example of a piping diagram. You can zoom in if required. If you require any other information, there is a direct link to the business portal. Remember the beginning of this video? You can start an EDoctor session from scanning a new QR code or by continuing a previous session. If you select Quit, EDoctor will close, but first you can save the page of your troubleshooting. This way, when you are back on site, you can start up your session where you left off. This is the end of our EDoctor introduction. We hope EDoctor will help you in your future troubleshooting of our Daikin units. We will keep you informed about new developments of EDoctor. In case you have any questions or comments about EDoctor, eCare or Stand By Me, your local branch will be happy to help.
All right, okay, so let's carry on. On the EDoctor or the eCare app, basically, as I explained, that's where you'll find it. That's what the symbol looks like on when you purchase, or not purchase, when you download it. So it's a free app from the sites on Apple and Play Store. Okay, and once you go in, you'll be required to enter an email address and password. You will need to register on the Daikin portal, the European portal, which I spoke about earlier on, in order to have access to this app. Don't try and go through any of the other things that it might take you through. Okay, the My Daikin is the portal that you go into. Okay, and you enter your credentials, and the app will then open up for you. Sorry, I'm just having some problems here with the presenter view. Okay, all right. So My Daikin EU is where you get access to it. Okay, fill in all the things that need to be filled in for registration. Okay, complete everything. You'll see again, information is mandatory. And then after you've done that, you will then be able to access the app. I'll just ask everybody if you could just turn off your microphones. Thank you. Okay, well, starting with the EDoctor, I think the video gave you a good idea of what it's capable of. You'll find that it's mostly the new products that are being loaded onto it at the moment. Okay, so I wouldn't try and do any searches on it for something like VRV2, but you will find that it's very, very helpful for the split sky air, and I've seen some pretty good stuff coming through now for the VRV fault finding as well, as we've been using it. So it's getting better all the time as more and more information is loaded up. Okay, so basically, once you get into EDoctor, you can do the quick search where you can start a new session. And these are what the screens look like. I'm not going to spend too much time here. I think the video did a pretty good job of it. And like all apps, they require some sort of time spent in playing with them and getting a good feel for how they operate, and taking them to site and using them as part of your fault finding and installation process. Okay, so you can do a quick search on error codes. Okay, there, choose one. Basically, there we're looking for a C9 error, and it says that it's a room thermistor abnormality. Okay, and it's basically resistance is out of range. What will it do? It will stop the unit from operating, and it will automatically reset when the resistance returns to range. Okay, so if it was a faulty sensor, you'd have to replace that sensor. Okay, you can go through your symptom and error-based troubleshooting, component check, and then also look at the component repair, which will hopefully tell you how to remove that item and to replace it. Okay. All right. Other component checks are available, and these are for indoor unit fan motors. There's an indoor unit PC board, plate work, the swing flat motor, thermistors, electrical circuit, refrigerant circuit, and external factors. If you chose a indoor fan motor, for instance, and you tapped on that, then it would bring you up with the checks that you would need to perform. Okay, basically there. Okay. And then also it can link you to eParts if you're registered on there. Okay, so that's just another application, but if you're not registered, don't worry too much. Hi, sorry, can I just ask you to mute your microphones? Thanks. Okay, then of course there's the Daikin Service App. This is a pretty old app. It's tried, tested. It's still pretty good. Not updated as regularly as the eCare has been updated. but a lot of guys are familiar with this. Again, it's a free download on both for Apple and Android. Okay, so let's go back there. Basically, once you've installed the application, you open it. You've got 3 options. You can choose VRV, or thermal, or split and sky air. Okay, and then you can go in there and you can see it'll give you a menu of which you can then choose what you want to do, what you want to look at. Here we're looking at advanced outdoor settings. Okay, that takes you into things like the refrigerant recovery mode, which you're going to use for putting a vacuum in for recovering refrigerant. And manual refrigerant charge mode, forcing the indoor units on, forcing the thermostat on. Forcing of the indoor units is also very good if you've coded up a unit and you find that you're missing indoor units. By using this app over here, or this part of the app, you'll be able to turn on indoor units, and the ones that don't come on are the ones that the condenser cannot see. Okay, you can also, it'll tell you how to adjust the static pressure on the outdoor fan, and you also your inverter transistor check modes, as well as adjusting evaporating temperature settings. Okay, so if there's any warnings, please take note of these warnings and adhere to them. Okay, they're there for both your and the equipment safety. Okay, once you've accepted that, it will then give you an option to either choose VRV3 and prior or VRV4 and higher. And you'll see, remember, we went from the LED display to the 3-segment display in the condensing units, which makes life a lot easier. Okay, so you select whichever one you want by tapping on it. Okay, here we've tapped on for VRV4. You then go through and it gives you a step-by-step. As you swipe on your screen, it takes you through a step-by-step process telling you what to do and what you should be seeing. Okay, and then how to make that change. Here, what we're doing, if you're familiar with this, is we're going to mode 228. So we're now doing a transistor check mode. Okay, and we're activating that. Okay. Right. Okay, you can also put in your error codes. Okay, and your error codes, you'll see down here in the bottom of the app, you've got 4 tabs. And we've gone through the system. We're now looking at the error codes. You can put in U4 with the newer error codes that have a number after them, which helps you pinpoint the error a bit more finer. You put in the number with no dashes, so it'll be U401 or U403. Okay, you don't put any dashes or anything in, you just put it in as a straightforward error code with the assisting number. Okay, and then that will take you through and it'll tell you about the error code. Okay, and then again, there's a difference on the Apple and the Android. Apple allows you to go a little bit deeper into the getting some wiring diagrams. It is available as well on some of the newer Android. So just to note what version you're using. Okay. The next part of the app allows you to also check thermistors. So here we've got thermistor. If we put in a temperature value over here, it'll tell us what the air and coil sensor resistance value is and what a discharge thermistor value would be. Remember, your discharge sensors above your compressor run on a different scale to the rest of the thermistors in a VRV unit. Okay. We covered a lot of this a couple of weeks back when we did the VRV advanced fault finding, and that recording is up as well. Very interesting, this little information button. It's there, it helps you out if you tap on it. Okay, and it will give you an idea of what the plug looks like and how to test it. So there'll be little information, things in there that just help you drill down a bit further. Transducer check. Okay, so pressure transducer. Again, your options here, you can either do voltage to pressure or pressure to voltage. Okay, and there if you put in a value, okay, doing the pressure to voltage, then what happens is it will then kick out a voltage over here. So here we've entered a pressure and here we are now going to get a voltage out. And remember, what you're testing, you need to remember whether you're doing a suction or discharge. You'll see the values are different. Okay, all right, again, the information button, very important on this one over here because it gives you the wiring diagrams for each of the low and high pressure and it'll be able to help you in determining which pins you need to be measuring the voltages across. Okay, remember it's got a fixed 5-volt voltage and a floating 5-volt which moves according to the pressure of the unit. Okay, right, there's also some other items in the system. Okay, additional tools, a refrigerant comparator, okay, which allows you to select the refrigerant you're working on and then get the pressure temperature relationship of that. Okay, right, there's also some questions, frequently asked questions, like what voltage should I have on the F1, F2 communication, and the answer of the 16 volts DC. Okay, right. You can also use the split sky airside for helping you on that over there. That gives you an approach for using the handheld remotes to get error codes out of. Okay. All right. I'm going to ask now that we've completed the first session, are there any questions? Okay. Right. Is everybody still there?
Yeah, we all hear you.
Okay.
Well, I can hear you.
Okay. Thank
Yes,
you
I'm
very
here.
much.
Thank you.
Okay.
Yes, we
Thanks
are.
a lot, guys. Okay. Right. I just want to just do a quick check just to make sure that we're still recording with that little glitch that we had just now, because sometimes it does throw the recording out. If you just give me a moment, and then we'll be back and we'll carry on with the second session. We're still recording. Great. All right. Okay, so we're going to go into the second part of this afternoon's session. Okay, and we're going to look at the indoor unit installation. Okay, we're going to look at Daikin VRV indoor units, the types. We're going to look at the placing of the indoor unit, refrigerant piping, just a very basic. We're going to cover that in more depth next week. Okay, drain piping, very important. We'll look at a couple of things to remember about ducts. And we're going to look at what we call the second leak test. Okay. All right, so indoor unit installation, and let's get on to that. Okay, so Daikin has a variety of indoor units, okay, to suit many applications. We have round flow cassettes, we have 4-way blow cassettes, 2-way blow cassettes, we have a corner cassette, all of them with different model numbers. Very, very important that when you have issues that you quote these model numbers, especially when you're seeking advice from service engineers and also when you're looking for spare parts. Incorrect model numbers will get you incorrect information. Okay, there's some more. These are ducted units. Okay, so we've got FXDQ, small concealed, then we've got a slimline FXDQ, FXSQ as a medium static, and FXMQ high static, and then of course the big boys, FXMQMs. All right. Okay, our mid-wall splits, FXAQ, then CD suspended cassettes, 2 varieties of those, and then floor standing as well. Okay, there are many other units that can also be connected to our systems. Okay, these include some of the Sky RA units. They will be connected through BP boxes or expansion valve kits, boxes, shall I say, and also hydro boxes. Also purpose-built air handling units. Okay, we don't do the little air curtains in South Africa. Okay, or the air recovery ventilators. So that's not pertaining to us. Placing the indoor unit. This is the important part for the installation. Okay, the indoor unit must be able to operate easily. Okay, so it's very important that you put it in a location where it's going to be able to give a good account of itself in cooling down or heating up a room. Okay, The remote controller cannot be influenced by direct sunlight, so do not place remote controllers on walls that have direct sunlight on them. And we've seen this done a number of times, and it causes the unit to overcool areas. Okay. Discharge air must not be drawn in again, creating an air bypass. So basically, we don't want the air to short circuit from the unit. So don't place the unit in areas where the air is going to bounce back directly into its return air. It's also going to cause the unit to short circuit or short cycle. And also the drain water must be easily extracted. We don't want indoor water features. We need the water to be able to be transferred outside and away from the building, okay, in a way that it does not damage either the interior or exterior of the building. It's very, very important to remember that. Okay, often drainage is something that is not considered until it's a problem. And then it often becomes a big thing to repair. Okay, make sure the wall is strong enough to support the full weight of the indoor unit. Okay, there's lots of dry walls in offices, and we need to make sure that those have been installed in a way that they can handle the full weight of the unit. Okay, that the unit can deliver the capacity and optimum airflow to condition the installed room. It's very, very important. The other thing to remember, that servicing is possible afterwards. We've always got to think of that poor guy that's got to come along and service, and he's often the guy that finds out that you can't get to the filters or to the drain pipe when there's issues. Yeah, so those things should be taken care of at the installation of the unit. So very important, and I know it's a difficult thing on some installations, but they need to be things that are spoken about and documented if you feel that they're going to be an issue, so that when they do come around, nobody can say, oh, but you didn't tell us. The unit should also not be exposed to electrical interference from other equipment. Okay, so if there is other equipment, and today we see even some of these Wi-Fi repeaters can be problematic to units, so we need to just take care of that and make sure that the unit is installed that it doesn't have any interference. Also make sure that it's not exposed to oil mist or dirt. And here you can see this is in a kitchen and over a machine where obviously there's a lot of cooling liquid being thrown into the air. This will clog up the filters and even eventually the coils, reducing the ability of the unit to cool or heat, and eventually causing damage to compressors because you're reducing the airflow. Inside the manuals, the installation manual that we supply, take note of the dimensions given for a correct installation, okay, pertaining especially to minimum distances away from objects. Okay, these are very, very important. We often come across units that are installed with obstacles in front of the airflow, and this only causes the air to short circuit and not to be able to cool down the entire room. Okay. So things like air vents, lights, machines near the unit, they must not interfere with the airflow. Okay, and you'll see here is an example taken out of a manual, and basically it gives you an idea of the type of distances that we're looking at. All right. Very, very important to take note of. Okay, here's a couple of more examples. Again, cassettes. Okay. And I'm showing you these basically so that you're aware that these are inside the documentation, and that they do exist, and that there are measurements given. Okay, all right, so just be advised that they are there. Okay, we also, when placing indoor units, select a place where the air passage is not blocked. Over here you can see somebody's hung clothing up, and here the unit is being completely boxed in. Okay, which doesn't help at all. Okay. Ceiling cassettes, these are designed to sit in flat ceilings, not in angled ceilings. You might laugh at it, but I think if you've been on the internet, you'll even find photographs that show where people have tried to install units like this, cassettes. Okay. Also take note that the unit must be installed where there's no risk of flammable gas leaking and no potential explosive atmosphere. Okay. And this is very, very important, especially around things like LP gas and other chemicals that may be stored near units. Okay, just to take note. Okay, on the refrigerant piping, we just got again a short video, and you're going to watch the video, and at the end of it I'm going to tell you yeah, that there's one thing missing which we should have, well, which we would have liked to have seen. So okay, yeah, I think the thing on there that was missing was him actually cleaning up the piping on there. I think he had done it, but yeah, it's just something to remember in terms of doing flares. A lot of times when we come across refrigerant leaks, we still find that the biggest culprit for leaks are badly prepared pipe ends before the technicians actually flare them. Okay, there's some talking distances, but there's different methods. Okay, then yeah, don't over tighten, but ensure that you've tightened enough on there. Okay, so okay, also remembering on the refrigerant piping that once you've installed the piping, that you use the insulation that we give you to cover the flare nuts. I can't tell you how many times we sit and I sit in buildings and I look up at the ceiling around cassettes and things like that, and in the one corner there's a telltale mark that the flare nut was never insulated by the leak marks or the water marks that are on the ceiling. And often it happens, and you see in new buildings, brand new ceilings, in a short space of time, you can see the telltale marks of the insulation that has not been installed on the flare nuts. Please make sure that it's part of the installation, and if you can just get that in, go a long way to not having damaged ceilings. Okay. Next one we're going to look at is obviously very often the very first call out that you get back to the system the day after it's been installed, and that is the condenser drains leaking. All right. Again, here's some images basically showing you we don't want to see the drain pipe going uphill first. Water does not flow uphill unassisted. Okay, so we don't want any U-bends up there, especially when there's no pump in the system, and mid walls do not have that unless you're installing one. But try and get away from that if you can. Okay, and ensure that you have sufficient fall on your piping. Okay, and no sags. So the piping must be supported at regular enough intervals that the piping or the PVC piping that you're using does not sag. Okay, and start looking like the ocean, because all of these become air traps and eventually you're not going to get the water flowing through it. Okay, so we recommend a 1 to 100 gradient, okay, sloping downhill. And the easiest way to get this is a bit of fishing line tied onto a bracket and a spirit level, and you just drop the spirit level down until you get one bubble, which is that first line flowing away from the unit, and that'll give you sufficient flow away from the unit. Okay, pipe hanging should be every 1 to 1.5 meters. Okay. Pay attention that nothing is stuck in the drain piping. We've seen, yeah, in the years that I've been, and I must say it's happened to me. If you're busy gluing piping and you're applying too much PVC glue, often you can actually form a blockage. So yeah, so make sure that there's nothing stuck in the pipe, no glue plugs, and nothing shoved in there because somebody was busy getting rid of their cigarette packet or something while you weren't watching. Okay. Also, drain piping should be in a separate piping from sewage piping, okay, to prevent odor, okay, from going back into the building, and also all the other things that grow inside sewage pipes. Installing a trap in the vertical line will help for odor while the cooling mode, the trap is filled with drain water, but in heating, when there's no water in the trap, the odor will travel up the pipe, and this often happens in the winter months. We start getting some bad smells coming back through the aircon units because the P-traps have dried out. Okay, and then insulated drain piping that is installed in a ceiling or wall. Okay, that's also just to stop it from sweating and dripping onto the ceiling tiles or causing a damp patch on the wall. Okay, you will also know that some of our units, our cassettes and ducted units, have drain pumps fitted in them It's important when installing those units now to remember what their maximum lift is. Okay, these do help you in installing the drain. And also make sure that you use the correct size piping. You don't want to oversize this piping because you don't want too much water flowing back into the unit every time the unit switches off. Okay, so take note of that. Also be aware that the distances can be measured from the ceiling tile on cassettes. Okay, ducted units, because they can sit above the ceiling tiles, their reference would be from the outlet of the unit. So just take note of that when you're looking inside the installation manual for the indoor unit. Where are they referencing this 850 millimeters from? Okay, then using common drains, make sure that the common drain is always sloping down. Okay, if you've got pumps available, you can pump up higher than unit, making sure, remember, that you don't exceed the maximum lift of the pump. Okay, and that the drain then flows downhill from there. Okay, correctly supported. It's also important to note where the refrigerant drains need to be. Okay, if there's a pump available, okay, make sure that you've got in the right place. If there is no pump, don't put your drain pipe at the top. You've got the unit upside down. All right. Okay, so we're going to, from there, just some more examples of common drains. Okay, remember, if you are going to come out of the unit, come out smoothly. If there's no drain, you're going down. Don't allow for zigzagging in your pipework. It's only going to cause more problems for you. Ensure that the end of the drain is able to release the water. Don't place it into sand or something where it's just going to back up and eventually cause a leak inside. Another important thing to remember, that the drains for mid-wall splits must flow down through the wall, not up. And also that drain pan should be filled with water once you've done the installation to ensure that they are that the water does flow out of them. Okay. Ducts. Okay, so if we're looking at ducting, okay, what we need to know on ducting, okay, is that obviously that is the unit at 1. Okay, 2 is the flange. Okay, so you've got a flange on both the return and supply air side. Connection screws that go into there. Make sure that these are correct connection screws. Don't go and make them too long. You don't want to go drill into something that's inside the unit that you don't want to, like piping and coils and things like that. Okay, so use the correct screws. Aluminium tape just to close up the seals and the edges. Okay, and then obviously insulation material, the correct insulation material for the environment in which you're installing. Okay, and obviously in different areas you can get away with thinner, but it's always important to have a look at what the SANS codes are regarding the insulation materials. Okay. All right, so we attach the ducting, intake and side flange. Okay, those are field supply. Connect the flange to the unit, and then we wrap the intake side flange and duct connection areas with aluminium tape or something similar to prevent air escaping. Okay. And when attaching the duct, be sure to attach the air filter inside the air passage. Okay, on the intake side, okay, use an air filter whose dust collecting efficiency is at least 50% of the gravimetric technique. Okay, an included filter is not used when the intake duct is attached. Okay, so if you've got an intake duct over here, don't go and install the filter in the back of the unit. Okay, that if you're going to use the filter, you're either going to put it at the return air grill, okay, or you're going to put your own, maybe an RAG with a return air grill with already a filter media in it. Okay, then you would not need to use the Daikin filter. Do not put 2 filters in line. Okay, and please don't fit the filter and then put ducting over it, because at some stage somebody's got to get in there to get it out and clean it. Okay. The outlet side, yeah, so basically you get the same thing there, and yeah, make sure that connect the ducting according to the air inside and the outlet side flange, and then wrap the outlet and the duct connection area with aluminium tape. Be sure to insulate the duct to prevent condensation. Okay, and glass wool, polyurethane foam, 25mm thick minimum. Some environments, some places might even need to be done with 50mm. Okay. Use electrical insulation between the duct and the wall. Okay, when using metal ducts. Okay. So it also helps us remembering to also provide an earth to your ducting. Okay. And be sure to explain about the way of maintaining and cleaning the local procurement. So the air filter, the grills that to your customer. So basically, when you hand over the job, these are the type of things that you need to make your customer aware of, is where the service access to the unit is, where you get access to the filters, and those type of things. Okay, something else to remember, just very briefly on this one over here, is that the return air and discharge are in the same room. Okay, they should never be in separate rooms. Okay, so you don't want to influence, that's going to negatively influence the performance of the unit. Pay attention to the duct external static pressure, okay, and the unit's external static pressure. On our medium static units, you may need to adjust this. You've got quite a range, and on our high static, you've got an ability to adjust as well on the smaller ones. On the FX DQs, you've got, those are low static, you've only got 2 options, and those units are generally designed for bulkhead applications. So don't go add long runs of ducting onto low static units. And particularly remember that when using flexible ducting, you lose a lot, okay, of static pressure. So try and keep those as straight as possible. Pull the kinks out of them, pull them as straight and as few bends as possible when you're using it. And in actual fact, you should only really be using about 1.2 to 1.5 meters of ducting from the main sheet metal duct onto any air register, okay, diffuser. The ducting is too long with lots of branches exceeding the ESP, the air discharge will not travel to the room. Okay, so if you exceed the ESP of the unit is not going to supply sufficient air. Okay, all right, and remembering that by increasing the ESP, you naturally are speeding up the fan, so you need to make note that that will also cause noise. When we talk about noise, doesn't necessarily mean that it's going to be unbearable, but there is an increase in the sound. Okay, and depending on your application, that may be a bit of a problem if they're wanting a very, very quiet environment. Okay. Common installation practice, remembering that our ducted units can also give you the option of putting the filter in the back or in the bottom of the unit. Okay, so that can be moved around. Okay. And then, of course, once you've got your indoor unit in and you've got the piping in, what you should actually be doing is doing the pressure test on just those items. Okay, it's very important. One of the things that we try and encourage the technicians to do is to do a number of pressure tests on a site. Pressure test your main piping separately. Pressure test your indoor units separately. If you've got many different floors, try and pressure test each floor individually before you connect the system up as a whole. This allows you that if you have a leak in the system, you can identify it to a smaller area and it takes less time to find. If you try and do the pressure test at the end, when you've got a system supplying 3 floors of air conditioning and another 5 floors of vertical riser and a condenser that's meters away, suddenly you're looking at a lot of piping to try and find a leak in. And sometimes you're only looking for a leak that's like a pinhole, okay? And it can take months to try and find leaks like that, okay? So try and pressure test in stages, all right? And that way what you're actually going to achieve, okay, is something like this, where you're pressure testing these units, okay, with a gauge on the end. Okay, so you lift up the pressure and then you do your pressure test. Okay, and that will save you a lot of heartache if there is a leak in the system. All right, this graph pertains to the different pressure testing stages. Okay, and so basically you take it to 0.5 bar. It's a rough leak check. Check your flare connections. Walk around with your ears. Make sure that you haven't missed a weld somewhere. Generally what will happen is the pipe will pull out of the socket. Okay, then you can take it to 1.5 megapascals. Also rough check confirming welding connections, and then anywhere between 35 and 40 bar. Okay, do not advise that you go above 40 bar. Okay, do make sure that your gauge is calibrated correctly. Okay, and your regulator as well, that you're not going to overpressure and burst any pipes, okay, or damage indoor units. Record the outdoor. Any pressure test always begins, okay, always requires you to log the outdoor ambient temperatures at the start of the pressure test, okay, and then record them again on the day that you come to check them, a minimum of 24 hours later, okay, and then check the deviation on there. If you are unsure and you feel that the deviation is borderline, then give it another 24 hours, okay. It's rather do that and lose one more day than end up losing 3 or 4 days now having to look for leaks. And yeah, especially when you get down to the vacuum and you can't get vacuum on the system, and then you've got to go back and redo the pressure test. Okay, then release the nitrogen pressure, okay, after 24 hours or more, and that's the end of the pressure test. Okay, it's an idea to log these as well. Okay, and it's important, I think, for the technicians to log those pressure tests, and even if it's with photographs, okay, I put a bit of masking tape over a gauge, and I write on there the date, time, and temperature at the start, and the date, time, and temperature at the finish. And you just take a photograph of it, and then you can say, right, there we go. And here are some installations that are probably not so good. Here we've got an indoor unit, and here's the remote controller on the wall. And obviously when this indoor unit's blowing air, it's blowing air directly onto the remote controller. Remember, wired remotes have a sensor in them, okay? And this is going to cause the unit to short circuit. So remember your placement of your remote controller. Don't put it in an area where the air from the unit or from a diffuser is going to blow directly onto it, okay? The next thing to have a look at is don't put units close to smoke detectors, okay, and newer type smoke detectors have a bit of a problem because they don't use the radioactive ones anymore in determining the difference between mist and smoke. So we don't want to be setting off fire alarms unnecessarily, okay. And there's a smoke detector over there, and also sprinklers. Keep units away from sprinklers. Okay, here's another installation mistake. Make sure that the insulation on the drain pipe covers the last elbow if you're using PVC elbows. Otherwise, that is going to start to sweat. Okay. Here they've taken the flexible pipe and they've bent it straight away, going straight up. Okay. The flexible fitting that is supplied with an air conditioning unit, okay, is to give you some linear movement, not angular. Don't turn it into an angle fitting. Okay, it's there to allow for some linear lineup, okay, not to be turned into an elbow or 45-degree bend or U-bend or whatever you might choose to do with it. Also ensure that supply air and return air registers are sufficiently spaced, that they do not cause short-circuiting. Remember that in short-circuiting with VRV equipment, okay, the unit will just start to step down to a minimum capacity and not be able to supply the required amount of cooling to the space. This is another one. When things are blocked up, they're normally telltale signs that somebody got irritated with it. It was blowing cold air onto it, and then it's something that needs to be investigated, because once one person blocks one of these up, it can actually create a snowball effect down the line for other people on that supply air duct. Okay. Again, also make sure that access to filters is possible. Okay, here we've got an access door, but not much room on there as well. Okay, and okay, and there's, yeah, make sure that, yeah, from different discharge from the rooms. So this is the above one room supplying to another. Okay. And over here, if you can see at the back here, you can see that these filters are blocked up, and this was even before the unit got to be commissioned. So very important once you install units, to reduce the ability for other people on the site to start turning units on. Okay, the unit should only be turned on by the commissioning engineers on the day of commissioning. Once other people start using them, they will start to abuse them. Okay. All right, here's piping. You can see this drain piping that's not installed too well. Okay. And over here we've got partly blocked off diffusers and things like that, which are not recommended. Okay, right, so we're going to the end of the indoor units. Are there any questions? Okay. Is everybody still there?
Yeah.
Sorry.
Yeah, go ahead.
Yeah. During installation, how frequent do Daikin inspectors or technicians come to do the inspections?
Okay, there isn't a frequency. Okay, there isn't a frequency, but what we would really like to hear from the guys is when they're starting an installation, if they could notify us, and we will actually document that, and then we will start to build in. And what we need to do is tie up with you guys and say, when are you hanging indoor units? When are you doing piping? That's the type of thing we'd like some sort of program, and we can say, right, can we come and do an inspection on site? And preferably before it becomes expensive to change things. Okay. So yeah, there isn't a set frequency, and the biggest problem with it is that we're not aware of installations taking place, because sometimes some installations happen quickly, other installations happen over a period of 2-3 years. So we would like the communication with the project managers to say, why don't you just come and throw your eye over our installation and see if you can see anything. We've done training with consulting engineers over the last couple of years, and part of that was also just to make them aware of things to keep their eyes open for, so to give us a second set of eyes on site, and where we also offer our services to join the consulting engineers on a walkabout from time to time. All right. Does that answer your question?
Yeah, that's perfect. Thanks.
Yeah, sure. Any other questions? All right, should we continue? Yeah. Outdoor unit installation. Okay. Outdoor units. Okay, we've got a number of outdoor units available. Okay, the ones for the South African market are RXYQ. Okay, we've got REYQ, REMYQ, and then we've got VRV replacement, RXYQQ. Okay, we've got water-cooled VRV. Okay, these are compact. Obviously, they don't have a condenser. They're installed indoors, but coupled to some sort of cooling tower. Okay, and then we've got compact series mini, which is RXYSCQ, and then the minis RXYSQ VRVs. Okay, and these are quite popular for apartment type projects, where each apartment can have its own VRV system. But then also you'll notice when we do next week in the piping, I'm going to talk about the differences in terms of piping requirements for the minis and the large frame VRVs. Okay, so placing of the outdoor unit. All right, so very important, okay, that the outdoor unit is placed in such a manner that it does not disturb the neighbors. Now, Daikin units are some of the quietest units on the market. Okay, but that does not mean that if you place it outside somebody's window, they're not going to hear it. Okay, so it's very important that that is taken note of, because we don't want units to be waking people up or keeping them up all night. And like I said, they are quiet, but sound has a habit of being amplified depending on the surfaces that it bounces off of as well. And again, that's something that we will discuss in the installation next week. All right. So again, I spoke earlier on, but also condensing units, same rules. Check the local legislation. make sure that the unit can be installed in the position that it's not adjacent to gas installations or gasoline or other products that could be flammable. Okay, we don't want these things mixing. We don't want to start a fire. We're there to air condition and not to destroy property. Okay, so very important that these things are taken note of. If you have concerns on site, when you see the placement of a condensing unit, and I have seen condensing units placed very, very close to gas installations, you should make, especially at the installation, the relevant people aware of it. Okay, just in case the changes need to be made. Okay, make sure that there's no obstacles around the condenser. Okay, for airflow, condensers, just like indoor units, do not like air recirculating. All right, also make sure that there's easy access for service. We don't want to see service engineers dangling on the end of buildings just to be able to work on a unit. Okay. Once again, the structure that it's mounted on, okay, must be able to withstand the weight and vibration of the unit. Okay, which means as well that no recirculation, air is not obstructed, causing discharge air to into the air intake, therefore causing a bypass. Okay, and over here, select a place where the outdoor unit is not exposed to the exhaust of other systems. In other words, oil, mist, dirt, things like that. Here you can see there's a unit hidden away behind this VRV condenser. And over here we can see that there's a duct discharging air onto this, and somebody's being very clever to put up a piece of board to try and fix the problem. Okay, we don't want the air influenced in any way. Okay, something else to be considered. Okay, and we've had this as well. This has happened in Cape Town, where units were installed very close to cell phone towers on roofs. And obviously everybody's competing for the space on top of buildings nowadays, cell phone companies especially. When this happens, we need to make sure that the unit is definitely going to need screen cable. Okay, and try and keep the units as far away as possible from these devices. Another place just to consider with screen cable, and I will mention it again, is if you're working on hospitals. Okay, and then later next week we will choose, or we'll look at screen cable in a bit more depth when we look at wiring next week. And other diagrams, okay, that you'll find inside the manual also give you an idea of the distancing away from walls. Okay, and you also need to just take note of these diagrams. Some of them will give you the actual wall height, so you can, as the wall increases in height, so this distance increases as well. Different options for plant areas. For instance, here you'll see that the arrow denotes the air intake on the condensers. Okay, so here we need 2 service aisles. Okay, and those distances on there, okay, would obviously take up more space. What we can do is we can rotate them around and create 1 service aisle. So we need to be a bit more creative. In some instances, we can create 1 aisle for the air. And again, I'm going to just, when we look at that next week, we have just a couple of options. But these are some of the things that you're going to find inside the installation manuals. Just make yourself aware of them. And there is a manual available for condenser plant room design, which the sales engineers can get to you. It's a more in-depth manual that shows some of the research done into the placement when you've got large volumes of condensing units. And Daikin has got a manual available for that. Yeah. Right, and this over here shows you again when they talk about H1 and H2, okay, and how to read those off of the diagrams. Something along the coast, which is very important, okay, and that is to be aware that salt air will find its way into anything, okay, if you're very, very close to the sea. Okay, A is depicting the sea wind. We have a building, okay, we have an outdoor unit. If we place the outdoor unit on the front of the building, we need to create a windbreak to try and drive out some of the salt so we don't get direct salt air. If it was placed on the roof, we would also need to put a windbreak on there to try and protect the unit, okay, and the better place would be to put it behind the building, okay, and allow the building to be the windbreak on there. Something to just remember that we've seen such levels of salt buildup on units that there's actually been arcing taking place between the electrical terminals of the unit and also damage to PC boards. So be aware of that. If units are to be installed in this type of environment, the units also need to be treated. Okay, we would recommend a higher level of treatment when you're in a coastal environment or an industrially aggressive environment. So if you've got things like acid rain or certain chemicals in the environment. We've seen a catalytic factory in Port Elizabeth where the corrosion was quite severe as well around the factory area. So be aware of the type of environments that you're installing into. It might not necessarily be C that's a problem. It could just be some of the fallout from the actual processes taking place in the factory itself. So in those cases, we would recommend that the additional treatment is put onto the units, and that in more severe cases that you also treat the PC boards. And there's some very good products available that are on the market now, things like nanotechnology that also repel dirt and things like that from PC boards and give a very good level of protection. And also to make sure that the switch boxes that you use the foam provided to try and close them up as much as possible. That's to keep out all the creepy crawlies that climb into the units as well. Okay, and we've also spoken that there's no risk of flammable gas leaking and no potentially explosive or corrosive environment. And that's what we've been discussing. Select a place as well where the unit has a chance to extract drain water. That's just a bad translation. Basically, to discharge any drain water during the defrost cycle. And that also make provision for removing defrosted water, the defrost water. Don't allow it just to flow out the bottom of a unit onto somebody's paving or into an area where people might be walking. That ground around there will eventually get algae and it becomes slippery, becomes an occupational safety problem. Okay, so just keep that in mind with defrosting, that you provide access for the water to move away from the unit. Okay, then refrigerant piping. We're going to, like I said, this is just a very quick overview because we're looking at condensers. Obviously, there's refrigerant piping that's going to connect onto them. This gives you a table of the sizes of the piping according to the unit's capacity. Okay, and this obviously you'll see this goes up to multi-condensers as well. Okay, and then obviously when you've got multi-condensers, outdoor 1, 2, and 3. Okay, and if we go on, then also looking at the different branch kits that might be required, making sure that when you pick up a branch kit out of the container or wherever you're storing your products, that you pick up the right ones that you need for a particular condenser set. Look at your schematic and make sure that you're selecting the right ones and that you don't get up there and then because it's a long way back, you're tempted to try and make a plan, which is not going to be very good for the unit. Okay, so there we've got the two different branch kits that are recommended, X and Y. Okay, you see. Okay, then also take note of the following. This can save you a lot of heartache as well. When we get to looking at gas risers just now, look at the access points provided and recommended for condenser piping configurations. And you'll see that the 3 of them that are recommended are in through the front, okay, and either in left or right underneath the unit. Okay, a lot of guys are tempted to take the piping out the back of the unit, and we try and advise that you don't do that because you start adding extra lengths of piping onto it, which could cause a problem and create extra work for you. So quite a nice way of doing it is to do the piping underneath the unit. This protects the piping from people standing on it. I find that when the piping is in front of the unit, very often you'll see after a while, you'll see it's bent back because every technician who has to get inside the electrical panel has to stand on top of the piping. And this just causes a problem. And it can also cause the ref nets on multi-systems to crack. Okay, so basically that's the 3 configurations. And the one that I really would I recommend is that the guys use going underneath the unit, okay, rather than coming in through the front. Something to remember about these branch kits in the front of the unit. Okay, we all know that with VRV there are certain distance rules that are required with ref net joints. At the condenser, the only one that pertains is the 500 millimeters coming into the ref net joint from a bend. Okay, basically these ref nets, they replace the old T-pieces which were not very good or conducive to getting oil return. Ref nets do a much better job when they're installed correctly of balancing the oil return back to the compressors and the condensers, which is very important for the life cycle of the unit. These must always be mounted horizontal. That is the only way they can go. You cannot mount the pipes vertical like that, where they're one above the other, okay, or even the whole ref net joint at the condenser in the vertical plane. They must be horizontal. You do need the 500 mils minimum straight piping into it, but once you come off this bend, you do not need 500 millimeters and then a bend. You can go straight off into that. That is the one time you break the 500 millimeter rule, and that is when installing at the condenser. And I'll show you if we go to the next slide. If you look at the diagrams supplied in the manual, they show the T-piece directly in line, or this is now the ref net, directly in line with the service valves. Okay, you do not need to mount them back 500 mils. Right, so just take note of that. These T-pieces, they do represent the outdoor connections, which are now ref nets. Right, so we have a look at those over there, just to go over that one more time. The ref nets at the condenser must be horizontal. You do need to have a minimum of 500 millimeters of straight piping entering into the ref net, but coming off of the ref net, you do not need 500. You can bend straight away and go in. So effectively, this bend must be in line with the service valve that it's going to connect onto. All right, so just keep that in mind. You may not install them vertically like that. Okay. If we come to site like that, we are going to make you change them. All right, reason, actually, rather than just telling you that, the reason is that you must understand that the oil traveling along this pipe, okay, is going to be traveling generally because of gravity near the bottom, and more oil is going to flow along the bottom than flow along the top, okay, which means that you're going to get uneven oil distribution back to your condensers, and eventually one condenser set will have too much oil and the other condenser set in the front of the piping will have too little, and both of those circumstances will cause damage to compressors, too much and too little oil. All right. Okay, so inside the manual, you also find that it gives you some patterns for installing piping. The ones with a 0, that's the ones that you may adhere to. That's what you're expected to install it as. So here you'll see the piping can be level with the intake. It can come underneath the unit. Okay, you can even slope it up. Okay, or like that, a slight slope. Okay, but horizontal is perfect. You may not bring it in above the height of the service valve. The reason being is that the oil, again, will tend to fall out into the first unit. Okay, so just be aware of that. Okay, and make sure that you're not installing along these lines over here. There's a couple of more of them. Okay, so over here, I've had this question before. Are these three ref nets going to different condensers? No. What this is showing you, okay, you'll see each of these ref nets connects into the same condenser. This is showing you that if you were to place this ref net above the service valves, it is not allowed. If it is horizontal or level with the service valves, it is allowed, and below it is also allowed. And there's just another view of it. Okay, so that is why you see the three ref nets there, not because that's a system with multiple condensers. Don't see it like that, because if it was multiple condensers, you would only have 2 ref nets, because the maximum number of units to be connected are 3. Okay, that's just giving you an idea of where you can place them. Right. Okay, on topic over here again, do not come in above. It's the same type of thing. Even if you come in above and then go in and under and below, you haven't solved the problem of the oil wanting to go to the first unit. Okay, you've still got the same issue there. Okay. When units are placed at different heights, and this can happen especially when the guys are installing on the side of mountains. Okay. You will find that you need to take particular note to the correct way of installing. You cannot come in at a height where the first piping is above these service valves and then going underneath. The piping must be below the lowest unit service valve and then go up. Okay. And then in the instance over here, when you're coming in like that, you can put a gas riser on the unit into the last one in the last unit. Okay, so take note of these. And this is an area where we do tend to pick up some problems from time to time. It's not common that condensers are at different heights, but when they are, we just take a photograph, send it to us, say, am I getting this right? You know, or come to site, can you pop past before we pipe up? We're going to have an issue. We'll come to site gladly and have a look at it and advise you. It's nothing wrong with asking the question. It's a yes, no, and at the end of it, we all learn. You know, it doesn't matter how long you work with the products and with Daikin, you're constantly learning, and that includes the service engineers that work for Daikin. All right. Okay, the other thing to consider is that sometimes it happens that condensers are not evenly spaced or spaced according to the manuals, and you'll be quite surprised that in an area where there's free airflow, no obstructions, condensers can actually be placed 25 millimeters apart, which is very close, okay? And that allows for less piping at the condensing end. But when you cannot put them close together, okay, then the type of thing that you're going to have to look at is using a gas riser, because once this piping extends past 2 meters, you're required to put a gas riser of 200 up, 200 across, and 200 down. Here's an example of a photograph. This is a case where the piping came in from behind into the condensers. It's been done very, very neatly. And because this piping flowing around, because of the back, you've got the width of the unit plus the piping over here through the ref net, okay, you have got to end up putting in a gas riser. And the gas riser only goes in gas pipes, okay, not in the liquid line. So remember, on a 2-pipe system, will go in the suction gas pipe, or we call the suction line. In a heat recovery system, both gas pipes will have one of those installed into it. Okay, never ever put it in the liquid line. All right, something else to remember when placing condensers down on an installation is that the highest capacity is where the piping enters, okay, and it scales down. Capacity B being less than A and C being less than B. Okay, so there's how they try and depict it. Okay, don't go and put the smallest unit in the front and the biggest unit at the end. Don't do it that way around. You will end up having to change it. All right, so just be aware of that. Okay, so capacity, the way it slides down is also very important. Okay, installation foundation. Okay, so make sure that the plinths are built in such a manner that they can withstand the weight of the unit. Also take note of the following. This is one of the commissioning it's on the commissioning checklist, okay, or the pre-commissioning checklist as well. On double fan units, okay, you may not only support it on the corners, you must support it either with 6 TICO pads, if you're using TICO pads, okay, or you can use supports like that, okay, or a support across the whole of the bottom like that, okay. I've seen this done recently quite successfully. This is the more common method of doing it, okay, using the 6 TICO pads. The reason for this is that the middle of the unit, the compressors tend to be, that's where the weight is in the unit, and you need to make sure that that doesn't sag in any way, okay, because it pulls the panels out of alignment and causes the unit to generate quite a bit of noise. It is a requirement to bolt units down, and believe it or not, we've had 300 kg condenser units blown over in the wind in Cape Town. Okay, quite something to go and see when you get up on a roof and find a condenser lying on its side, and the end result of that was 2 compressors that were damaged because they pumped their oil out. All right. Okay, so take note of that. Units must be bolted down. Okay. All right. So the next one is we're nearing towards the end of our afternoon session over here. Is how to lift a unit, and we've got just a short video. All right, so yeah, quite a lift. I think if I think back to my days in the industry with lifting things, it was often that day that was actually quite stressful because quite a bit of planning had to go into it. So in terms of that as well, often when we arrive on site, we see damage to units, and it becomes pretty obvious that it was because the lifting was never done properly. Slings are too tight, they start pulling the top of the unit in, and then we see the telltale marks of sling damage and things like that. So take note of the lifting requirements. They're inside the installation manuals as well, and ensure that if you are subbing out your lifting to a rigging company, that they are made aware of those as well, that they don't arrive on the day with slings that are too short, and then they try and get away with it and they end up damaging the units. Okay, there's different lift points inside the unit, and these are all marked off as well. Okay, and then also that if spreaders need to be used, these diagrams don't show, but spreaders are also a good option. Okay, all right. So the next one is removing of the transport brackets once the units are down and on their final location. Okay, the transport bracket can be taken out. This is usually yellow, unless it's been blue chemmed, then it will be blue. These need to be taken out, and then the bolts tightened down, but not tightened all the way. Okay, and again, you've only got to go basically one turn back to get it loose, and then no more than about 3 turns around. So don't go and tighten it down to that you squash the rubber. Just needs a couple of turns just to take up the slack to make sure that there's no movement, no excessive movement. Okay, so that there's. All right, then once that's done, you are basically ready to start your piping, which we will talk about next week. Then removing the pinched ends. Okay, believe it or not, we've had systems where we've gone to commission and to find that the piping is blocked, only to find that when the guys welded the piping onto the unit that they hadn't removed the pinched end. They just sleeved the piping over and welded it up. Okay, it's very important also to take note. Make sure that the stop valves are closed. Okay, vacuum any gas from the pinched piping by using a vacuum unit through service ports, the outdoor unit. Okay, or you can recover the gas and oil from the pinched. I think most times the guys will just clean it out, make sure there's no excessive gas. Make sure that the valves have not leaked as well. Okay, you can do this by checking the service valve on top. Okay, and that will also help you as well. That's once you've got the piping connected, that you don't have any issues. If there is a slight leak, maybe it's come ajar on transport, that for the rest of the time while you're busy doing piping, in the last stages, you're actually losing gas as well, or refrigerant. Okay, and so basically that's what we're looking at over there. Okay, then once you're ready, you can cut that piping off, cut it off on the mark that's on there. Okay, you don't need to cut it too high, and also remember that once you weld, protect the valve as well. Okay, so make sure that you don't overheat the work there. Okay, and use the correct size nozzles for doing that as well, and so the correct amount of filler material. All right, so that actually brings us to the end of the 3 sessions of all the 3 items that we're going to cover this afternoon. They were pretty basic. Next week we're going to get into a bit more detail, so it will be a bit more intense. I'm expecting to get more questions out of you. But on the condensers, or from anything this afternoon, are there any more questions? Right. Okay, I take it there's none coming through there. Bill, are you still there? I just wanted to see. Okay, all right. All right, well then I'm going to close off. Guys, thanks very much for joining us this afternoon. I look forward to you guys joining us next week. And as I said, next week we're going to be looking at the piping, wiring, and the pressure testing. Okay, and evacuation. Yes?
Sorry, Antonia. When you do pressure testing, do you use nitrogen?
Yes, definitely.
How does the temperature affect the nitrogen pressure then? So in your presentation said by the gauges, the pressure temperature will change if the temperature changes.
Okay, all right. So for all gases, if you have any change in temperature, you will have a change in pressure. Okay.
Does that affect nitrogen as well?
It affects nitrogen as well, but nitrogen is what was the term? I think it was a noble gas that it was probably the closest to a perfect gas.
Yeah.
And so it's got least affection, but also it's got the least effect. It's inert, so it's not going to react with like if you pumped. You don't want to put oxygen into something. Okay, never ever pressure test with oxygen, because if there's any oil in the system, you can cause a diesel effect where it can ignite. Okay, and especially the pressures that we're looking at, because for the diesel effect you need to be above 1,600 kPa. Okay, and that's very possible when you're pressure testing. So you don't want that type of thing. So we use nitrogen. It's inert. We asked for that they use medical grade nitrogen, so it should be dry and clean. So we're not going to introduce any contaminants into the system. But yes, it is affected by temperature. All gases are. So any change in temperature will cause the pressure to deflect. And that's why it's very, very important for a pressure test that your gauges should be tagged in some way that tells you the time and date that you started in temperature, and the time and date and temperature that you finish, as well as the pressure on the start and finish. And when you start seeing deflections outside of what you would expect, like I said, rather take another 24 hours to be certain than drop it and think you're there, and then when we come to pull a vacuum, we can't get it and we start the whole process over again.
Okay, cool. Thanks.
Yeah. All right, sure. Any other questions?
I'm good, thank you.
You're good. Okay. All right, gentlemen, I'm going to close off this afternoon session. Thank you very much. I look forward to seeing you again next week.
Thanks, Glenn.
Thank you. Go well.
Right.
Thanks,
Yep.
Glenn.
Thanks.
Thanks, Glenn.
Thank you. Thank you. Bye.
Right, Glenn.